In this video, we will explore and implement the concept of cosine similarity, which is a method for measuring the similarity between text documents. Before watching this video, it might be helpful to check out another video that explains the conversion of text into numerical form using techniques like the document term matrix and TF-IDF. When we have various documents, being able to determine the degree of similarity between these documents can be valuable in a wide range of applications, including information retrieval, document classification, recommendation systems, and more. So, how can we assess the similarity of documents? In a previous video, we explored various methods for representing documents in a vectorized form so that computers can understand them. To illustrate this concept with a simple example, let's assume we have two documents, text 1 and text 2, and we've represented them as vector A and vector B. When you position two vectors in a two-dimensional coordinate system, a smaller angle between them means they are pointing in a similar direction, while a larger angle indicates they are pointing in different directions. Therefore, if two vectors are in the same direction, there's a higher probability that they have similar meanings, and if they are in different directions, there's a higher probability that they have different meanings. This is how cosine similarity works. It measures the similarity between documents based on the angle between their vectors. First, let's explain an important aspect when calculating cosine similarity, which is the dot product of vectors. The dot product is an operation that combines two vectors to yield a single scalar value. In this illustration, we have two vectors, A and B, and let's assume an angle theta between them. The dot product of two vectors, A and B, is represented as A dot B, and it's equal to the product of the magnitudes of the two vectors and the cosine of the angle between them. If we consider that the two vectors are in a two-dimensional coordinate system, the dot product of these two vectors can be defined as the sum of the products of their respective components, A1b1 plus A2b2. The magnitudes of the vectors are represented as the square root of the sum of the squares of their individual components. The square root of A1 squared plus A2 squared for vector A, and the square root of B1 squared plus B2 squared for vector B. To summarize, the cosine of theta is calculated by taking the dot product of two vectors and dividing it by the product of the magnitudes of the two vectors. The cosine value falls between -1 and 1, depending on the angle between the vectors. This allows us to measure the similarity between two vectors. In other words, by converting text into numerical vectors using various text encoding methods like TF-IDF, as explained in the previous video, we can use cosine similarity to measure how similar documents are to each other. Now let's understand how we can determine document similarity using cosine similarity. Let's assume we have two documents, text 1 and text 2, represented as vectors A and B. When we position these vectors in a two-dimensional coordinate system, the cosine value approaches 1 as the angle between the vectors approaches 0. This means that the two vectors are pointing in a similar direction, and we can consider the two documents to be similar. Conversely, when the angle between the vectors is 90 degrees, the cosine value becomes 0, indicating that the vectors are orthogonal, and we can conclude that the two documents are dissimilar. As the angle between the vectors approaches 180 degrees, the cosine value becomes -1, representing an opposite direction. In this case, we can infer that the two documents likely have opposite meanings or are very dissimilar. Now let's calculate cosine similarity using English sentences. We have three sentences. Lee likes apples, Lee likes bananas, and Lee likes bananas and Lee likes bananas. We represent them as vectors using the bag of words method. For Lee likes apples, the vector is 1, 1, 1, 0, 0. For Lee likes bananas, it's 11010, and for Lee likes bananas and Lee likes bananas, it's 22021. Calculating the magnitudes of each sentence vector results in root 3, and root 13 respectively. The dot products of the sentence vectors are 2, 6, and 4. Using the cosine similarity formula, we find that the cosine similarity between sentences Lee likes apples and Lee likes bananas is 0.67. Between sentences Lee likes bananas and Lee likes bananas and Lee likes bananas is 0.96. And between sentences Lee likes apples and Lee likes bananas and Lee likes bananas is approximately 0.64. So the sentence pairs with a cosine similarity values closer to 1 are considered more similar. In this case, sentences B and C have the highest cosine similarity, indicating that they are the most similar. Now let's calculate cosine similarity through coding. You can find this Jupyter Notebook file on GitHub and run it yourself. First, we import the NumPy library and the necessary functions for calculating dot products and vector norms, along with the count vectorizer library to numerically represent text data based on word frequencies. We store the three sentences, Lee likes apples, Lee likes bananas, and Lee likes bananas and Lee likes bananas in the documents variable. Next, we use the count vectorizer command to build a vocabulary list. Then we calculate cosine similarity using a function that computes the dot product of two vectors divided by their magnitudes. As a result, we can obtain the cosine similarity between any two sentences, like so. In conclusion, the highest similarity is between documents 1 and 2, which are Lee likes bananas, and Lee likes bananas, and Lee likes bananas. This matches the theoretical result we calculated earlier.